Hi everybody, welcome to Video Notes 1A and 1B, Scientific Method Measuring, Scientific Notation, and Significant Figures. It's our first one, yay! Okay, so 2 objectives are covered in this PowerPoint, and so 1A, I can create and carry out a viable way to test a hypothesis, and 1B, I can take measurements and observations in a way to ensure valid and replicable laboratory experiments. Let's get busy. Chemistry is the study of matter and the changes that take place in matter. So make sure you have that definition in your notes. Look at all these changes going on. Look at all this matter. So matter is anything that has mass and takes up space. Another way to say take up space is volume. So anything that has mass and volume is matter. It's pretty much everything except ideas and energy. Gas is matter. It does have mass. This is matter, but he's matter. Okay, so what do scientists do to study this? Well, we collect data and figure things out using a certain method. Now, it's not a specific method. It's just an approach. So you might have a question, how to answer it, gather data, state an answer, do a new experiment, or have a new question, or come up with your conclusions. So it can be a circular kind of process where you might have to refine. It could be linear. You use the scientific method when you did your exploding stomach. So we came up with a question, you designed an experiment to test it, you probably had a prediction about it. So one thing to realize is that a good research question has a hypothesis that's testable. Okay? It's a testable prediction. And so if you went outside and your car wouldn't start, your hypothesis could be that the car won't run because the battery's dead. That's testable. You can test that. The car won't run because evil spirits have taken it over. That is not so testable. Okay, so just keep in mind that a hypothesis is a testable prediction. So experiments should also have a control. And a control is a comparison group to see if the effect of what you are examining is what's going on, to see the effect of what you're examining. So maybe your question is, does LT water make you sick? So 100 kids drink water from the fountain at LT, and 100 kids drink tap water brought from home. What's the control group? So which one is going to be used to compare the effect of what we're examining? Well, here's what we're examining, LT water. So this is our control group. Oops, the O disappeared. Control group is the one that we're going to compare to what we're testing. Okay, observations are directly detected by your senses with or without an instrument. So there's 2 main types. Qualitative observations involve, can't spell, come on, Harbin, involve your 5 senses and are reporting, and they report, okay, qualitative observations involve 5 senses and report the qualities or characteristics. I know it's a little messy, but I'm also saying it as I write it, so without measuring. Okay, so reporting the qualities or characteristics of matter without measuring is going to be a qualitative observation. Quantitative observations involve and are expressed with numerical values and measurements and numerical values. Okay. So the quantitative measurements will involve an instrument. All right. Measurements are done scientifically, and each one contains an estimated digit. So the estimated digit is the one that you can't see a marking for on the instrument. So here we're trying to measure the pen, and we see the 4, so that's the ones column. We see the tenths column, we see the next tenths column, but they're in between, which would be the hundredths column, we have to estimate. So the estimate for this one is the 3, in 4.73. So measured digits are called significant figures because they're measured, and every measured value has an estimated digit. Okay, so someone might think this is 4.72 or 4.73, but you have to have that estimated one. Sometimes it's called the iffy one, but scientists measure like that all the time. Okay, so measured values are significant digits, significant numbers. So what are significant numbers? They're the measured digits, okay? And if we all measure the same way, then we know there's always that one estimated digit is still considered significant. So all non-zero numbers, so 1, 2, 3, 4, 5, 6, 7, 8, any digit like that is significant, and trap zeros are significant if there's a zero in between numbers. So here's an example. 4.73 centimeters from the slide before has 1, 2, 3 measured digits. So it has what we call 3 significant figures. If you would have had 4.05, it has 1, 2, 3 measured digits. So it has 3 significant figures. Okay, so there are some times where it gets hard to decide, and it's when it comes to the zeros. So sometimes a measured a number could look like this. So we can't tell, was this measured, was this measured? We don't know. So we have to assume that zeros in front of measured numbers are not significant. Okay, so this value has 3 significant figures because these zeros are just holding the place to tell us that it's a small number, but these are the measured ones. Captive zeros, I called them trapped on the last slide. These are always significant. So this number has 4 measured digits, and they're all significant, 4 significant figures. If you see 23,000 and 34.00, well, you don't know. Looking at these ones, you can't tell where they measured or not, because there's nothing, there's no decimal place to help you. So we would say this is 2 significant figures because we have to assume these are just placeholders to show you how big it is. So those are the ending zeros when there's not a decimal point. But look at this one, 34.00. These are measured because of the decimal place. So this has 4 significant figures. Okay. One rule you can use, if you can tell, this is the United States of America. And over here we have the Pacific Ocean. Here we have the Atlantic Ocean. Put your number in the U.S. All right. So I got 22.330. I've got 0.00410. I'm just making these up, by the way. I've got 700. And I've got 4,318,000. Okay, look to see if your decimal place is there. Okay, if the decimal place is present in the number, you start on the Pacific side of the United States. So here the decimal point is present. So I start here and I find all the non-zeros. 1, 2, there's the decimal point, 3, 4, 5. So this has 5 significant digits because the decimal point present makes that significant. Okay, is there a decimal point present in this number? Yes, there is. So I come to the decimal point and I find the first non-zero digit. So I run here into the 410. So there are 3 significant figures in that number, but I have to find the first non-zero before I start counting. Okay, in this one, decimal point absent. Okay, so no decimal place. So I start from the Atlantic side and I find the first non-zero. The 7. There's only 1 significant figure there. Okay, and this number of decimal point is absent, so I start from the Atlantic side, find the first non-zero. Up, here we go. 1, 2, 3, 4 significant figures. So these are how many significant figures in those numbers. Okay, we'll keep practicing. So the one other thing we're going to have to be able to do is convert from scientific notation into standard and vice versa. So scientific notation looks like this or this. All right, and so this number in front of the decimal point is greater than 1 and less than 10 always. All right, and it can't be any different. So it has to be greater than 1 or less than 10. If you see it after, so here or here after the E, if you see a negative, it means that something is less than 1. Okay, so here's 2 examples of that. See the negative, the negative. If you see a positive, it means the number is greater than 1. Okay, it's more than 10. So the number, this number is always greater than 1 and less than 10, and this tells you that the overall number If it's negative, it's less than 1, but if it's positive, it's greater than 10. So let's convert. We have 2.55 E4. So that means 2.55 times 10 to the negative 4th. This is positive, so that means this number is big. So then we move our decimal point over 4 places, 25500. So it started here, I moved it 1, 2, 3, 4, and then standard notation is 25,500. Okay, here's our decimal point. It's a 7, it's a positive 7, so that means this number is bigger than 10. So we have to move our decimal point 7 places, 6. All right, so 1, 4. So we go 1, 2, 3, 4, 5, 6, 7. And I could always check by going backwards. 1, 2, 3, 4, 5, 6, 7. So this number was 6,001,000. I'm sorry, 61,400,000. Come on, Harbin, get it together. All right, we're back. Oh, look, it's another number. What do you notice? A negative this time. So this is scientific notation, converted to standard. This is negative, so that means this number is very small. It's less than 1. So I got to move my decimal point 8 places. So 1, 2, 3, 4, 5, 6, 7, and then the 8th place starts the number 3721. Okay, how about this one? Oops, the negative 4th. So that means it's a small number. I got to move my decimal point 4 places. 1, 2, 3. The 4th place is the 7, 2. All right. Finally, if we have a big number, we want to convert to scientific notation, then it's going to have a positive value after the 10 or after the E. So I start here and I go 1, 2, 3, 4, 5, 6, 7, 8. 9.87 times 10 to the 8th. All right, or you can write it as 9.87E8. Okay, last but not least, we got to convert this one. So this is less than 1, so it's going to be negative 1, 2, 3, 4, 5. After the 10 or after the E, it's going to be negative. So 2.10 times 10 to the negative 5th, or 2.10E negative 5. All right, hope you took these notes and put those examples in your notes so you have some examples. When you calculate with measurements, you can't be more accurate than your data. So do the whole calculation first, no rounding, and then use the limiting term to determine how to write your answer. So I got to teach you what the limiting term is. There's 2 different cases. When you're adding and subtracting, there's a rule, and that rule is decimal place limit. Okay? So let's look at it. 23.45 plus 45.991 plus 16.4. So I'm adding those all up and not rounding or anything along the way, and I get 85.801. Now, my answer can't be more accurate than my data. So I look at my data, I see this is my limiting. Why is it limiting? Because it has the least number of decimal places. It only has 1 decimal place. So I can't have more than 1 decimal place in my answer. So it's going to be 85.8 is my answer. All right, I do the calculation here, and I get 331.79. And I look back at my data, and this is my limiting because it stops at the ones column. All right, so I have to round my answer to the stop at the ones column. 330, that's 1, but look, this 7 makes that round up to 2. Okay, adding, subtracting, limited by decimal places. Multiplying and dividing are limited by significant figures. All right, so I would multiply these together, and I get a big number, 308,837. So I have to look at my data. This is my limiting factor because it only has 1, 2 significant figures. So my answer can only be 310,000, and that's it. I could also put that in scientific notation, 3.1, whoops, times 10 to the 1, 2, 3, 4, 5, 5. All right, last but not least, dividing. So divide like regular, and I get 25 point, here we go, 49765, 4976526. All right, I can't use that whole answer because this is my limiting factor. I only have 3 significant figures there, so that means it is 25 point, well, this 9 makes that a 5. There we go, 25.5. All right, to review, all right, read through this whole slide and know all this stuff, okay? And if you have questions, make sure to write them down in your notes what you just took, okay? Here are the 2 objectives that we were covering in this PowerPoint, and hopefully you get them. Peace out. See you in class.